What are the different forms of energy? Different forms of energy are heat, work done, and internal energy. These things will get transferred within each other. For example, if you do work on a system, so your work energy will be saved as internal energy within system if heat is not getting transferred. Or if you add heat to a system and work is not being done, then heat plus internal energy is what total energy that system will have. All right. So internal energy, heat Q, internal energy change delta U, heat Q, and work done W. So these things are interchanging within themselves. As you must have heard that energy can neither be created nor destroyed. Energy can neither be created nor destroyed, right? So we have first law of thermodynamics based on conservation of energy. So what is the first law? First law is delta U equals to Q plus W, where delta U is change in internal energy, Q is heat transfer, and W is pressure volume work. Alright, so we have this formula to calculate change in internal energy. Alright, what we have to do while solving numericals is just remember that we have to take the sign according to sign convention for the values we have been given. Alright, and we get the answer according to sign convention. For example, if I say that a system absorbs heat of 10 joules, then we will take as plus 10 joule, because for absorption Q is positive and system does work. That means work is being done by the system, and system does work of 2 joule. So sign work is being done by the system, so sign will be negative. So that is minus 2 joule. When you want to calculate delta U, you put these values in this formula. So delta U will be 10 minus 2, that is 8, plus 8 joule. That means you get the value according to sign convention. For delta U, there is not anything being told separately, but always remember, if any change, not internal energy only, any change, enthalpy change, Gibbs energy change, internal energy change, delta changes delta. If change is increasing, sign will be positive. If change is decreasing, sign will be negative. Here plus sign means internal energy is increasing by 8 joules. If it was something, let's say minus 8, that means we will say internal energy of the system is decreasing by 8 joules. Alright. So this is one example I gave you. Few more terms are there. Enthalpy means in chemistry we say heat content of a system. Total heat content of a system is called enthalpy of that system. Enthalpy will be calculated as delta H equals to delta U plus P delta V. That means change in internal energy plus pressure volume work done will be equal to enthalpy change. That is what I told you. Total heat content in a system. Another formula, very popular one, is delta H equals to delta U plus delta NGRT. Delta H equals to delta U plus delta NGRT. Alright. So these two formulas you will be using in most of your questions. Next term we have, we are done with first law, we are done with enthalpy, we are done with, now we are doing heat capacity. What is heat capacity? So if I give you a bucket of water and I ask you what amount of heat is needed to increase the temperature of this water by 1 degree Celsius. So what that heat required? So the amount of heat required to increase the temperature of any mass of substance is known as heat capacity. So what do you think? Heat capacity depends on mass or not? Or else I'll put an example for you. If I take let's say 10 liters of water. So heat capacity, that the heat required to increase temperature of 10 liter of water is capital C, and heat capacity or heat required to increase the temperature by 1 degree Celsius of 100 liter, will that be same? No. For 100 liter, the heat required to increase temperature by 1 degree Celsius will be greater than heat required to increase temperature by 1 degree for 10 liter. So heat capacity is a extensive property because heat capacity depends on mass. So heat capacity, what is heat capacity? I will repeat it again for you. Energy required to increase temperature by 1 degree Celsius. More the mass, more will be energy required. So more will be heat capacity. So it is extensive property. Next, we have specific heat capacity. What is this? It says energy required to increase temperature by 1 degree Celsius of 1 gram substance. That means you have fixed the quantity of mass. That means energy required to increase temperature of 1 gram substance by 1 degree Celsius is called specific heat or specific heat capacity. So heat capacity, the symbol was capital C. Specific heat is represented by small c or small s. Small s you can say lowercase, right? And next is heat capacity at constant pressure and heat capacity at constant volume. The energy required to increase temperature by 1 degree Celsius of 1 mole substance. Yes, you heard it right. You heard it right. Energy required to increase temperature of 1 mole substance by 1 degree Celsius is called molar heat capacity. Now it is of two types. Molar heat capacity is of two types. One is Cp and another is Cv. Molar heat capacity at constant pressure is called Cp and molar heat capacity at constant volume is called Cv. Alright. So we have two formulas for that. If you want to calculate delta H, you have Ncp delta T. So for delta H you have formula Ncp delta T. So you have Cp equals to delta H by N delta T, right? And Cp is molar heat capacity at constant pressure. Similarly, Cv is used for calculation of internal energy change. This is enthalpy change, this is internal energy change. So enthalpy change is heat transfer at constant pressure, and internal energy changes heat transfer at constant volume. So the formula is Ncv delta T, and molar heat capacity Cv equals to delta U by N delta T. Alright. So Cv is equals to delta U by N delta T, Cp equals to delta H by N delta T. Alright. So molar heat capacity at constant pressure is called Cp and molar heat capacity at constant volume is called Cv, and delta H is heat transfer at constant pressure, delta U is heat transfer at constant volume. Alright. So we are done with heat capacity at constant pressure as well as heat capacity at constant volume. Molar heat capacity I already explained you. The energy required to increase temperature by 1 degree Celsius of 1 mole substance is called molar heat capacity. So these are few formulas we will be using in thermodynamics.